Look at the back of your hand. Not a glance. A real look. Hold it up if you can. Or just picture it. The hand resting on your chest right now, or tucked under your pillow, or draped over the edge of whatever surface is holding you tonight. Look at the skin there. The tiny lines. The pores. The color, whatever color it is. Brown, pink, olive, deep umber, pale and freckled, golden, reddish, blue-veined, and almost translucent in the wrist. That color is not decoration. It is not cosmetic. It is not an accident of culture or geography or some shallow sorting of the world into categories that politicians argue about on television. That color is a scar, a biological scar, written into you by thousands of years of crisis, starvation, infant death, and one very specific molecule that your body cannot live without, but also cannot make on its own. Not without light, not without the right kind of light, and not without paying a price in your skin to get it. Tonight, we're going to talk about that molecule. We're going to talk about vitamin D. And before you think this is a simple story, some nutrition label factoid about milk and sunshine, let me tell you what it really is. It is the story of a genetic emergency, a mutation that swept through an entire population in what, by evolutionary standards, was a blink, a single blink. Thousands of years where the math of survival came down to this. Absorb enough ultraviolet light through your skin to keep your bones from dissolving and your babies from dying, or perish in the dark of a continent your species was never built for. Your skin color, whatever it is the answer your lineage found. And it nearly wasn't enough. Let's slow down for a moment. Breathe in. I mean really. Feel your lungs. Feel your ribs spread. Feel your chest rise against the fabric of whatever you're wearing, or against the cool of the sheets, or against nothing at all. Now let it go. Slowly. Good. You are lying somewhere on the surface of a planet that is spinning at roughly 1,000 miles per hour. You don't feel it. You never do. But you're moving. Right now. Hurtling through the dark on a ball of rock and iron and water, tilted at 23.5 degrees on its axis. And that tilt, that lazy, wobbling lean, is the reason we're here tonight. Because that tilt is what gives us seasons. And seasons are what made your skin the color it is. Not race. Not destiny. Not divine sorting. Angle of light. Duration of light. How many photons of a very specific wavelength, ultraviolet B, if you want to be precise, strike each square centimeter of exposed human skin in a given year. That is the pressure, the evolutionary thumb on the scale. And when your ancestors walked north, or south, far south, though tonight we'll focus on the northward migration, they walked into a place where that pressure changed. Dramatically, silently, over generations so slow that no single person could have noticed. But their bones noticed. Their babies noticed. And their genes, their genes kept a very careful record. Here is the paradox that should keep you curious. Just curious enough to stay. Just relaxed enough to drift if you need to. Modern humans, Homo sapiens, left Africa roughly 70,000 years ago. Some say a bit earlier. Some say in waves. We'll get into that. But the number that matters tonight is this. For approximately 200,000 years before that, every single human being on the planet had dark skin. Every one. Dark skin was not a variant. It was not a type. It was the original factory setting. The baseline. The only option on the menu. Deep, rich, melanin-saturated skin that did something extraordinarily clever. It blocked ultraviolet radiation from destroying folate in the bloodstream. Folate, the molecule you need to build a baby's spinal cord, while still letting just enough UVB light through to produce vitamin D in the lower layers of the epidermis. It was a beautifully calibrated system. Hundreds of thousands of years of equatorial sun had tuned it. Dark skin in tropical and subtropical Africa was, and still is, an engineering masterpiece. And then we left. We walked north, across the Sinai, or maybe across the strait at Bab el-Mandeb, through the Levant, into Anatolia, across the Caucasus, into the great forests and river valleys, and eventually the icy, gray, cloud-choked latitudes of northern Europe. And the engineering masterpiece started to fail. Not quickly, not like a switch, but like a dial being turned down, degree by degree, winter by winter, generation by generation. Less UVB reaching the ground, less penetrating the skin, less vitamin D being synthesized in the body. And without enough vitamin D, bones soften, they bend, they bow. In children, the pelvis narrows and deforms. In pregnant women, a deformed pelvis means one thing: death in childbirth. For the mother, for the baby, for the entire genetic line. Rickets, that's the word. An Old English word, probably from the Old English ricken, to twist. And it twisted its way through the bodies of every dark-skinned human who tried to make a life above the 46th parallel. So the body had a choice, not a conscious choice. Evolution doesn't think. It doesn't plan. It just filters. It filters the living from the dead, and it does it with absolute indifference. The filter, in this case, was light. And the answer, the mutation that passed through the filter, was a reduction in melanin. Lighter skin, skin that let more UVB through, skin that could manufacture enough vitamin D in the weak, slanting, gray light of a northern winter to keep bones hard and pelvises wide and babies alive. That is why skin turned white. Not culture, not superiority, not adaptation to cold. That a myth, by the way. Melanin has almost nothing to do with temperature regulation. Light, vitamin D, bone density, pelvic width, infant survival. That is the chain. That is the pressure. That is the scar. And it is written on the back of your hand right now. Now, before we go any further into this, before we walk through the genetic evidence, the ancient DNA, the fossils, the molecular archaeology that maps exactly when and how this mutation spread, I want to do something. I want to ask you where you are. It's late, isn't it? For most of you. That's the deal with these kinds of videos. You're in bed, or on a couch, or in a chair that's slowly winning the argument with your spine. You got headphones in, or the phone is propped on a pillow, or the laptop is glowing on a nightstand, and your eyes are half closed, and the screen is the only light in the room. And the room is somewhere. Maybe you're in London, and it's 2 in the morning, and the rain is doing that thing London rain does. Not falling, exactly, but just being, hanging in the air like it forgot where the ground was. Maybe you're in Istanbul, and the call to prayer was hours ago, and the city has gone quiet the way Istanbul goes quiet, which is to say, not entirely, because there's always a ship on the Bosphorus, always a dog barking in Katakoy. Maybe you're in Michigan, and the furnace kicked on 20 minutes ago, and the house is making those sounds, those small, wooden, settling sounds that houses make when the temperature drops and the timbers contract. Maybe you're in Manila, and it's early, and you're not trying to sleep at all. You're just here, listening, letting someone else carry the weight of thinking for a while. Wherever you are, whatever time it is, whatever your skin looks like in the light of the screen, you're welcome here. This is your story, every word of it. It belongs to you because you are the result of it. You are the living, breathing, blinking proof that this crisis was survived, that the mutation took, that the filter didn't catch your line. So stay, or drift. Both are fine. If you fall asleep, the story will still be true in the morning. Let's set the stage properly. Let's talk about time. Not clock time. Not the kind that makes you anxious. Deep time. Geological time. The kind of time that makes your mortgage feel like a raindrop on the ocean. Imagine all of Earth's history, all 4.5 billion years of it, compressed into a single 24-hour day. A day that starts at midnight and ends at the next midnight. At midnight, the Earth forms. A ball of molten rock and colliding debris, glowing orange in the dark of a new solar system. By about 4 in the morning, the first simple cells appear. Bacteria, archaea, tiny, single-celled organisms drifting in a hot, iron-rich ocean under a sky with almost no oxygen. For the next 16 hours, almost nothing else happens. Cells divide. Cells drift. Cells eat and excrete and die. That's it. From 4 a.m. to about 8:30 p.m., the most complex life on Earth is still microscopic. 16 hours of microbial patience. At about 8:50 p.m., the first animals appear. Soft-bodied things. worms and fronds and strange, quilted creatures that look like they were designed by a committee that had never seen an animal before. At 9 p.m., the Cambrian explosion. Eyes, shells, teeth, predators and prey. The arms race begins. At about 10 p.m., the first fish. 10:30 p.m., the first land plants. 10:45 p.m., the first insects. 10:56 p.m., the dinosaurs arrive. 11:39 p.m., the asteroid hits. The dinosaurs are gone. And humans? Homo sapiens appears at approximately 11:59 and 56 seconds. 4 seconds before midnight. 4 seconds. Your entire species, every pharaoh, every ice age migration, every cathedral, every war, every lullaby ever hummed to a restless baby at 3 in the morning, fits into 4 seconds of 24-hour day. And the migration out of Africa, the one that triggered the skin color change, that's about 1/5 of a second before midnight. A blink. You are living in the last fraction of the last second of the last minute of the day. And the crisis we're talking about tonight, the vitamin D crisis, the lightening of skin, the genetic bottleneck that decided who lived and who didn't in the forests of Europe, that happened so recently, in deep time, that the Earth barely had time to register it. But your body registered it. Your body is still registering it. So here's the mystery we're going to solve tonight. Not all at once. Slowly. The way you'd examine a fossil, brushing away the sediment with a fine brush, layer by layer, until the shape emerges. The mystery is this. How fast did it happen? Because here's the thing that surprises people. Here's the thing that surprised the geneticists when they first sequenced the relevant genes. SLC24A5, SLC45A2, TYRP1, OCA2, and a handful of others we'll explore together. The lightening of European skin was fast, breathtakingly fast. For most of human evolutionary history, genetic changes are glacial. A beneficial mutation might take tens of thousands of years to spread through a population. Hundreds of thousands, sometimes. Evolution is not in a hurry. It doesn't need to be. It has deep time on its side. But the alleles for lighter skin in Europe, some of them swept to near fixation, meaning they became almost universal in the population in fewer than 5,000 years. Some researchers argue it was closer to 3,000. In evolutionary terms, that is not a gentle breeze of natural selection. That is a hurricane. That is selection pressure so intense, so lethal, that dark-skinned individuals in northern latitudes were dying. Or more precisely, their children were dying, at rates high enough to shift the entire genetic composition of a continent in a few hundred generations. Think about that for a moment. Imagine a population. A few thousand people, maybe scattered across the river valleys of what would one day be called Germany or Poland or Scandinavia. They hunt. They gather. Later, they farm. And farming, as we'll see, made everything worse. They build shelters. They make tools. They bury their dead with ochre and flowers, because even then, even in the cold and the hunger and the relentless gray of a northern winter, they loved each other enough to mark the loss. And in every generation, a few of those children are born a little lighter than their parents. A random mutation, a typo in the DNA, a single nucleotide polymorphism, one letter changed in a 3 billion letter book. And those slightly lighter children absorb a little more UVB. And their bones are a little harder. And their pelvises, if they're female, are a little wider. And their babies are a little more likely to survive. In over 5,000 years, roughly 250 generations, that slight advantage compounds. And compounds. And compounds. Until the population has shifted. Until light skin is no longer the exception, but the rule. Until the original, ancient, beautiful dark skin that served humanity for 200 millennia is, in this one corner of the world, selected against. Not because it was wrong. Not because it was inferior. But because the light was different here, and the body had to change to meet it. That is the story. It is not a story about race. It is a story about photons and calcium, and the width of a pelvis, and whether a baby lives or dies in a dark winter in a world before supplements, before fortified milk, before the little orange bottles in your bathroom cabinet. It is If you want to be precise about it, a story about a star. Our star. The same one that was shining when you woke up this morning, if you saw it all, depending on where you are and what the weather was doing. The same one that has been fusing hydrogen into helium for 4.5 billion years, pouring energy onto this planet in wavelengths your eyes can see and wavelengths they can't, and one of those invisible wavelengths, ultraviolet B, in the range of 290 to 320 nanometers, is the one that saved your ancestors, or killed them, depending on where they stood. Here is what we'll do, you and I, over the next little while. We're going to follow the evidence, like detectives, but slow ones, patient ones, the kind who don't mind sitting in the archive for hours, turning pages with cotton gloves. First, we'll go to the labs. We'll look at the ancient DNA, the genetic material extracted from teeth and skulls and femur bones pulled out of European soil, some of them 10,000 years old, some 40,000, and we'll see what color those people's skin actually was. Not what we assumed, what the genes say. And what the genes say will surprise you. Then we'll go to a day, a single day, a morning in the life of a woman. Let's call her that, a woman, because she was living in what is now southern Sweden, roughly 7,000 years ago. We'll follow her from the moment she opens her eyes in a smoky, half-underground shelter made of turf and timber, to the moment she falls asleep with a child pressed against her chest. We'll smell what she smelled, hear what she heard, feel the cold that she felt in her fingers, in her knees, in the deep ache of bones that are not quite right, not quite hard enough, because the sky in this place is overcast for 9 months of the year, and her body is slowly losing a war against the angle of the sun. Then we'll bring it home, to you, to your body, in your bed, under your artificial light, staring at your artificial screen, in a world where vitamin D deficiency is still one of the most common nutritional deficiencies on the planet. Not because we lack the science, but because we build a civilization that keeps us indoors, behind glass, under fluorescent light, in cubicles and apartments and cars with tinted windows, and our skin, the same skin that fought for millennia to find the right calibration, is now, once again, not getting what it needs. The crisis isn't over. It just changed shape. But that's later. For now, let's stay here, in the beginning of the thread. Let me give you one more thing to hold on to, one more strange, true thing, before we settle into the evidence. The gene most associated with light skin in Europeans is called SLC24A5. It codes for a protein that affects the production and distribution of melanin in skin cells. The specific variant, the allele, that causes lighter skin involves a change in a single amino acid, a threonine to an alanine substitution at position 111 of the protein. One amino acid, out of hundreds, in one protein, out of tens of thousands, in one body, out of billions. And that one swap, that one tiny molecular edit, is carried today by virtually every person of European descent on the planet. It is one of the most dramatic examples of a selective sweep in the entire human genome. One letter changed everything. And here's the part that unsettles people, the part that makes the old racial categories dissolve like sugar in warm water. That allele, SLC24A5, in its light form, it appears to have originated only around 6,000 to 10,000 years ago, depending on whose estimate you trust, which means that the ancient hunter-gatherers who lived in Europe for tens of thousands of years before that, the people who painted Lascaux, who carved the Venus of Willendorf, who survived the last glacial maximum huddled in the refugia of Iberia and the Balkans, many of them likely had dark skin. Dark skin, in Europe, for thousands and thousands of years. The Europe you picture in your mind, the fair-haired, pale-skinned, blue-eyed Europe of postcards and period dramas, is, in genetic terms, new, startlingly new, a product not of deep ancestry, but of a very recent crisis. A crisis of agriculture, of latitude, of clothing that covered more skin, of diets that shifted away from vitamin D-rich wild fish and game toward grain, pale, vitamin D-poor grain, and of winters that grew longer as populations moved further from the sun. The pressure built, and the body answered. And the answer is on the back of your hand. So rest your hand now. Put it back where it was comfortable. Close your eyes if they want to close. We're just getting started. In part 2, we will go into the evidence. The ancient teeth pulled from muddy graves in Hungary and Spain. The DNA extracted in clean rooms by scientists in gloves and masks, working under amber light to avoid contaminating samples that are older than writing, older than bronze, older than the very idea of Europe. We will look at what the genes say, not what we wish they said, not what fits neatly into the stories we've already decided to believe. What they actually say, letter by letter, in a language written in adenine, thymine, guanine, and cytosine. And it will be strange, and it will be beautiful, and you don't need to be awake for all of it. The story will carry you. It has been carrying your family for 100,000 years. It can carry you for one more night. Breathe in. Hold it for a moment. Let go. You are lying on the surface of a planet, in the dark, wrapped in fabric, listening to a voice describe the reason your skin looks the way it does. And that reason is light. And the light will be back in the morning. But for now, the dark is fine. The dark is where we rest. The dark is where the body does its quiet, ancient work of repair and renewal. The same work it has done every night since the first human closed their eyes by a fire on an African savanna and let the sounds of the world fade into the rhythm of sleep. You're the latest edition of a very old book, and we're going to read it together, slowly, one page at a time. There is a room in a building in Dublin. It is not a famous room. You would walk past the building and not notice it. It sits on the campus of Trinity College, behind old stone walls and metal gates. And inside it the air is filtered and the temperature is controlled, and the lights, when they are on at all, are a specific color. Not the white of an office, not the yellow of a kitchen, a dim amber, the kind of light that does not carry ultraviolet. Because ultraviolet, in this room, is the enemy. Not because it would hurt anyone, not because of skin or vitamin D or any of the things we talked about in the last chapter, but because in this room there are fragments of bone, small ones, some no bigger than the last joint of your little finger. And inside those fragments, tangled in the collagen and the mineral matrix and the slow, patient chemistry of decay, there are strands of DNA, ancient DNA, thousands of years old, tens of thousands, in some cases. And ultraviolet light degrades DNA. It snaps the strands. It scrambles the base pairs. It turns a readable sentence into garbled noise. So the lights stay amber. The researchers wear full-body suits, not lab coats, full suits, head to toe, with masks and double gloves and shoe covers. Because a single flake of modern skin, a single dropped hair, a single cough, would flood the sample with billions of modern DNA fragments and ruin everything. This is the world of ancient DNA research, paleogenomics, and it is one of the most extraordinary detective operations in the history of science. And it is where our story gets its evidence. Let me tell you how you read a dead person's genes. You start with a tooth, usually a molar. Teeth are the best source of ancient DNA because enamel is the hardest substance the human body produces. Harder than bone, harder than anything else that decays. And inside the tooth, in the pulp chamber and the root, DNA can survive for remarkable periods of time, especially if the burial conditions are right. Cool, dry, slightly acidic soil, no flooding, no extreme heat, no cycles of freeze and thaw that shatter the molecular structure. You take the tooth, a tooth that might have been pulled from a jawbone excavated from a Neolithic grave in Hungary, or a Mesolithic burial in Spain, or a Bronze Age cairn in Sweden, and you bring it to the clean room, the amber-lit room, and you drill into it, carefully, with a dental drill, not unlike the one your dentist uses, but slower, cooler, more precise. The powder that comes out, a fine, ivory-colored dust, contains, if you are fortunate, fragments of the original owner's genome. Not the whole genome, not even close. Ancient DNA is always fragmentary. Time breaks it into pieces, like a book left in the rain. Pages stick together. Ink bleeds. Sentences dissolve. What you recover is not the complete works of a human being. It is scattered words, phrases, sometimes just individual letters. But here is the miracle of modern genomics. If you have enough scattered words, and if you know the structure of the book, the reference genome, the map of where each gene sits on each chromosome, you can reconstruct sentences. You can figure out what the book said. And one of the sentences you can reconstruct is the one that codes for skin color. Let's talk about the genes. There is no single gene for skin color. This is important. The genetics of pigmentation involve dozens of genes, each contributing a small amount to the overall shade. But a handful of them carry more weight than the others, and those are the ones the paleogeneticists focus on. The first, and probably the most studied, is SLC24A5. We mentioned it before. It sits on chromosome 15, and it encodes a protein called NCKX5, which is involved in the transport of calcium ions in melanosomes, the tiny organelles inside skin cells where melanin is actually produced. The specific variant that causes lighter skin in Europeans is a single nucleotide change, a G to an A, that results in a 3-amine to alanine substitution at position 111 of the protein. What does that substitution do exactly? It appears to reduce the activity of the melanosome. Less active melanosomes produce less melanin. Less melanin means lighter skin. The mechanism is still being refined. Biology is never as clean as we'd like it to be, but the correlation is rock solid. If you carry 2 copies of the A allele and you are of European ancestry, your skin is lighter than it would be with the ancestral G version. And here is the key finding. Pay attention to this, even if your eyes are heavy, because this is the thing that changed everything we thought we knew. When researchers extracted DNA from the oldest European hunter-gatherers, people who lived in Europe 10,000, 15,000, even 40,000 years ago, they found that many of them carried the ancestral version of SLC24A5, the dark skin version, the same version that is still the dominant allele in sub-Saharan Africa today. Let that settle. People who lived in Europe for 30,000 years. People who hunted mammoth. People who survived the last glacial maximum, the coldest period of the last ice age, when glaciers covered Scandinavia and Britain and northern Germany, and the average temperature in southern France was roughly what northern Finland experiences today. People who carved ivory figurines and painted bison on cave walls and wore stitched furs and built shelters from mammoth bones on the frozen steppe. Many of them had dark skin. In Europe, for tens of thousands of years. And they survived. How? This is where the story gets layered. Where the simple version, dark skin bad in north, light skin good, evolution fixes it, starts a crack and reveals something more intricate underneath. Because the early European hunter-gatherers were not farming. They were not eating grain. They were eating what they caught and what they gathered. And what they caught included a great deal of fish, game, and organ meat. Fish, especially oily fish like salmon, trout, and eel, is rich in vitamin D3. So are the livers of large mammals. So is the fat of marine animals. So are eggs, when you can find them. A hunter-gatherer diet in Ice Age Europe, even at high latitudes, even under gray skies, could provide enough dietary vitamin D to compensate for reduced UVB exposure. Not perfectly, not without cost, but enough to survive, enough to reproduce, enough to keep bones hard and pelvises functional and babies alive. Most of the time, the skin could stay dark because the diet was doing the work the sun couldn't. This is a crucial point, and it is one that the popular narrative almost always gets wrong. It is not simply the case that moving north required lighter skin. Moving north required adequate vitamin D, and for thousands of years, diet provided it. The crisis, the real crisis, the one that triggered the explosive selective sweep, came later. It came with farming. The Neolithic Revolution reached Europe in waves, beginning around 9,000 years ago. It came from the Fertile Crescent, from what is now Turkey, Iraq, Syria, the lands between the Tigris and the Euphrates, carried by migrating farmers who brought with them domesticated wheat, barley, lentils, sheep, goats, and cattle. These farmers moved into Europe slowly, across Anatolia, into Greece, up through the Balkans, along the Danube, into Central Europe, then Northern Europe, then eventually the far edges of the continent, Scandinavia, the British Isles, the Atlantic coast, and they brought a new diet, a diet based on grain, wheat, barley, emmer, einkorn, foods that could be stored and measured and taxed and traded, foods that supported larger populations, denser settlements, the beginnings of what we would one day call civilization. But grain is essentially devoid of vitamin D. Grind wheat into flour. Bake it into bread. Eat that bread, morning, noon, and night, as Neolithic farmers increasingly did, and you're getting calories. You're getting carbohydrates. You're getting some protein, some fiber, some minerals. But you're getting almost no vitamin D. And at the same time, farming changed behavior. Farmers stay in one place. They clear fields. They build permanent structures. They wear more clothing, woven flax, later wool, which covers more skin. They spend long hours grinding grain, tending livestock, repairing walls and fences and roofs, tasks that can be done in shade or indoors. They are not following herds across open tundra under a wide sky. They are not standing hip-deep in a river pulling salmon from the current. Their diet lost vitamin D. Their lifestyle reduced sun exposure. And they were living at latitudes where UVB was already scarce for half the year. The trap closed. Now the pressure was real. Now the math was lethal. A dark-skinned farmer living at 55 degrees north, the latitude of Copenhagen, of Edinburgh, of Moscow, eating a grain-based diet, wearing woven clothing, spending much of the day indoors or in shadow, would produce catastrophically low levels of vitamin D during the winter months. And not just the winter. In Northern Europe, the sun's angle is too low to produce meaningful UVB exposure for 6 to 8 months of the year. From roughly October to April, you could stand naked at noon on the roof of your longhouse, and your skin would synthesize almost nothing. And the consequences were brutal. Children developed rickets. Bones that should have been hardening remained soft. Legs bowed. Spines curved. Rib cages deformed. And the pelvis, the bony ring through which every baby must pass at birth, narrowed and twisted. A woman with a rachitic pelvis faces obstructed labor. In a world without cesarean sections, without forceps, without anesthesia, without any of the interventions that modern obstetrics takes for granted, obstructed labor was a death sentence. For the mother, for the baby, often for both. And it was not just rickets. Vitamin D deficiency weakens the immune system. It increases susceptibility to respiratory infections, tuberculosis, pneumonia, the endless catalog of diseases that thrive in cold, damp, crowded Neolithic villages. It impairs wound healing. It affects mood, cognition, fertility. It makes everything harder. So the selection pressure was not gentle. It was not a mild statistical nudge. It was a scythe. In every generation, those who could produce more vitamin D survived at higher rates. Those who couldn't died, or their children died, or their children's children, which is the same thing genetically. And the fastest way to produce more vitamin D, given the constraints of latitude and lifestyle, was to reduce melanin in the skin. Let more light in. Let more UVB through. Let the photons reach the 7-dehydrocholesterol molecules in the epidermis and kickstart the synthesis chain that produces cholecalciferol, vitamin D3, the molecule that keeps calcium in bones and babies in the world. And so the alleles shifted. One by one, the variants that reduced melanin production were selected for, favored, amplified, passed from parent to child to grandchild to great-grandchild in an unbroken chain of survival. Not because lighter skin was better, not in any absolute sense. In tropical Africa, lighter skin is actively dangerous. It increases the risk of folate destruction, which causes neural tube defects in developing embryos. It increases the risk of skin cancer. Dark skin, in equatorial light, is the superior adaptation. Full stop. But in the gray, slanting, vitamin D-starved light of Northern Europe, lighter skin was a lifeline. And the genes knew it. Or rather, the genes didn't know anything. They don't know. They don't think. They simply exist in bodies, and some bodies survive and some don't. And the genes inside the surviving bodies get copied, and the genes inside the dead bodies don't. That is all evolution is. Differential survival. Differential reproduction. Repeated 1 billion times across 1 billion generations until the population looks different from how it started. Now, let me take you to a specific study, a specific finding, something to anchor all of this in real, published, peer-reviewed evidence. In 2014, A team of researchers led by Ian Matheson at Harvard, working with ancient DNA pioneer David Reich, published an analysis of genome-wide data from 83 ancient individuals spanning roughly 8,000 years of European prehistory. The samples came from sites across the continent: Hungary, Germany, Spain, Sweden, Russia, and the results rewrote the textbook. They found that the Mesolithic hunter-gatherers of Europe, the people living there before the farmers arrived, overwhelmingly carried the ancestral, dark-skinned version of SLC24A5 and SLC45A2. They also, many of them, carry the derived allele for HERC2/OCA2, the gene complex most associated with blue eye color. Read that again, and let it sink in. Dark skin, blue eyes. That was the face of Europe for thousands of years. Not the fair-skinned, fair-haired image we've been sold by a century and a half of bad anthropology and worse politics. Dark skin and blue eyes. A combination that essentially does not exist in the world today, because subsequent genetic shifts changed the pigmentation landscape entirely. The farmers who migrated into Europe from Anatolia, by contrast, carried the lighter skin alleles. They had been living at slightly lower latitudes, but, critically, they had been farming for longer. Their populations had been under the vitamin D selection pressure for more generations. The alleles for lighter skin had already begun to spread among them. When these farming populations moved into Europe and mixed with the indigenous hunter-gatherers, the lighter skin alleles entered the European gene pool. And because the farmers brought with them the very lifestyle, grain-based diet, settled living, more clothing, that made the selection pressure most intense, those alleles were immediately favored. The result was rapid. The light-skinned variant of SLC24A5 went from relatively rare to nearly universal in a matter of millennia. The geneticists call this a hard sweep, a signature in the genome where a single allele rises to high frequency so fast that it drags along the surrounding DNA with it, creating a distinctive pattern of low genetic diversity in the region around the gene. You can see in the data a smooth, deep valley of reduced variation on chromosome 15, centered exactly on SLC24A5, a valley carved by selection, by thousands of years of differential survival, by babies who lived and babies who didn't. There's another piece of evidence I want to share with you, not from a lab, from ice. In Greenland and Antarctica, and in the glaciers of the high Alps and the Andes, there are cores of ice that have been drilled from the deep layers of frozen water that have accumulated over hundreds of thousands of years. Each layer represents a year, a thin, compacted record of what the atmosphere contained in that particular season. Dust, pollen, volcanic ash, bubbles of ancient air trapped in the crystals. And from these cores, we can reconstruct the climate of the past with extraordinary precision. What the ice cores tell us about the period between roughly 8,000 and 5,000 years ago, the period during which lighter skin swept through Europe, is this. It was getting colder. Not dramatically, not Ice Age cold, but the long, warm Holocene optimum, the balmy period that followed the end of the last glaciation, the period that made farming possible in the first place, was beginning to wane. Winters were getting longer. Cloud cover was increasing. The already limited UVB window in northern Europe was narrowing further. The vice was tightening. Less sun, worse diet, more clothing, colder winters. And into that tightening vice, the mutation offered a way out. A tiny, molecular way out. One amino acid, one protein, a slight reduction in melanin, a slight increase in UVB absorption, a slight improvement in vitamin D synthesis. Slight. But in a world where the margin between a living baby and a dead one was measured in nanograms per milliliter of serum calcidiol, slight was everything. I want to give you one more layer of evidence before we move on. One more thread in the rope. Skin color, as we've said, is polygenic. It involves many genes. And the fascinating thing about the European lightning event is that different genes were selected at different times. It was not a single mutation that flipped a switch. It was a cascade, a series of independent mutations, each reducing melanin by a small amount, each favored by the same selection pressure, layering on top of each other over thousands of years. SLC24A5, the big one, swept through the population most dramatically during the Neolithic, the farming period. But other pigmentation alleles appear to have been selected earlier, during the Mesolithic, among the hunter-gatherers, and still others continue to be selected during the Bronze Age and the Iron Age, well after farming was established. This means that the lightening of European skin was not a single event. It was a process, an ongoing negotiation between the genome and the environment, playing out across millennia, and it is still playing out. There is evidence from genome-wide association studies of modern British, Scandinavian, and Eastern European populations that selection on pigmentation genes has continued into the historical period, into the last 2,000 years, possibly into the last few hundred. Your skin is not a finished product. It is an ongoing draft, a document that is still being edited by the quiet, implacable hand of selection, even now, even in a world of supplements and fortified food and sun lamps and plane tickets to the Canary Islands in February. The draft is never final. The pressure never fully relents. Let's stop here for a moment and breathe. This is a lot of information. And if you are still awake, truly awake, not in that soft halfway state where the words are more texture than meaning, then I want to acknowledge that. You're doing something rare. You're lying in the dark, listening to someone describe the molecular genetics of skin pigmentation, and you are still here. That says something about you. Something good. And if you are in that halfway state, if the words are washing over you like warm water, if the terms like SLC24A5 and UVB and selective sweep are dissolving into a kind of gentle hum, that is fine too. That is what this is for. The knowledge is entering your mind, not through the front door of active concentration, but through the side door of relaxed absorption. The state that sleep researchers call hypnagogia, the threshold between waking and sleep, when the brain is loose and receptive and the boundaries between categories blur. You are learning. Even now, even half asleep, the facts are settling into you the way sediment settles in a lake. Slowly, silently, grain by grain. So here's where we are. We know that modern humans left Africa with dark skin. We know that dark skin is the ancestral state, a sophisticated, precisely calibrated adaptation to high UV environments that protects folate and allows just enough UVB for vitamin D synthesis. We know that when those humans moved north into Europe, they initially survived with dark skin because their diet, rich in fish, game, and organ meats, provided sufficient vitamin D. We know that the arrival of farming, roughly 9,000 years ago, changed the equation catastrophically. Grain-based diets stripped vitamin D from the food supply. Settled lifestyles reduced sun exposure. Clothing covered skin. And at the same time, climate was cooling, reducing UVB even further. We know that under this intense, sustained selection pressure, alleles for lighter skin swept through the European population with extraordinary speed, some of the fastest selective sweeps in the human genome. We know that different genes were selected at different times, making the process a cascade rather than a single event. We know that the Mesolithic Europeans, the people who were there before the farmers, had a combination of dark skin and often blue eyes, a phenotype that has essentially vanished from the modern world. And we know that all of it, comes down to a molecule. Vitamin D3, cholecalciferol, a secosteroid that your skin produces when UVB photons interact with 7-dehydrocholesterol in the epidermis, which is then hydroxylated in the liver, then again in the kidney, to produce calcitriol, the active form, which regulates calcium absorption in the gut, maintains bone mineral density, modulates immune function, and influences cell growth. A molecule so essential that your body evolved an entire organ, your skin, partly to manufacture it. A molecule so sensitive to light conditions that a shift of 10 degrees of latitude could mean the difference between healthy bones and a skeleton that folds under its own weight. A molecule that is, right now, circulating in your blood, doing its quiet work, keeping you solid, keeping you together, keeping the calcium in your bones where it belongs, so that your spine can hold you up tomorrow, so that your ribs can expand tonight with each breath, so that your body, this improbable, temporary, magnificent body, can go on being a body for one more day. You are held together by a molecule that was once so scarce in your ancestors' blood that it reshaped the color of their skin. Think about that. Or don't. Let think about you. Let settle. We leave the lab. We leave the data and the gene names and the ice cores. We go to a morning, a single morning, 7,000 years ago, in a settlement by a lake in what will one day, in a language that does not yet exist, be called Sweden. A woman opens her eyes. The fire has gone to embers. The shelter smells of smoke and damp earth and the sharp, fermented tang of stored grain. Her child is pressed against her side, warm and still. She doesn't know about SLC24A5. She doesn't know about UVB or selective sweeps or vitamin D synthesis. But her bones ache, and the sky outside is gray, and she is part of the story that made you. Picture this, not as a scene in a documentary, not as a painting in a museum. Picture it as though you are there, as though the air is on your skin and the smell is in your nose and the ground is under your body. You are lying on your side, on earth, hard-packed earth, but softened, slightly, by a layer of dried reeds and a hide. Deerskin, the hair is still on it. You can feel it against your cheek. It is coarse and slightly oily, and it smells the way animal skin smells when it has been scraped and dried, but not fully tanned. A thick, biological smell, not unpleasant, familiar. The way your own pillow smells familiar to you. Not because it smells good, exactly, but because it smells like the place where you sleep, and that is enough. The air is cold on the half of your face that is exposed. Your breath makes a faint cloud, barely visible in the dark. But below your chin, below the edge of the fur you have pulled up to your jaw, you are warm. Body heat, trapped. Your child is pressed against your stomach, curled like a fern, knees drawn up, one small hand gripping a fold of the hide. You can feel the heat of the child's skull against the underside of your chin. The fontanelle closed months ago, but you still think of it. You still lay your lips there sometimes on the top of the head, where the bone knitted together, and feel the warmth come through, and think. Asterisk alive. Still here. Asterisk. This is the first thing. Before the day begins. Before the light. The child is alive. The night did not take it. This is not a small thing. You have buried one already. A boy. In the ground behind the settlement, near the birch trees, wrapped in linen that took you 3 weeks to weave. The linen is probably gone by now, rotted, but the bones are still there. Small bones. You try not to think about how small. So every morning begins with this inventory, this unconscious check. Warmth against your body, breath on your collarbone. Wait, presence. The mathematics of survival performed before you even open your eyes. The child is here. The morning can begin. No leaves. Birch and alder bare. Late winter. The sound of a landscape holding its breath before spring. You open your eyes. The shelter is dark. Not completely. There's a faint glow from the fire pit in the center of the floor, where a few embers are still breathing under a layer of ash. Orange light, pulsing, like something alive and slow and patient. The smoke from last night's fire hangs in a thin layer near the roof, which is made of overlapping birch bark and turf, supported by timber poles. The smoke finds its way out through a gap of the ridge. Slowly. It is never fast enough. The air in here always tastes of smoke. Your hair smells of smoke. Your skin smells of smoke. Everything you own has a fine layer of soot on it. The pots, the tools, the grinding stone in the corner, the dried fish hanging from a cord near the wall. Smoke is the background flavor of your life. You do not notice it the way a fish does not notice water. You sit up, slowly. Your lower back aches. It has ached for months, a deep, grinding pain in the vertebrae that gets worse in cold weather. Your knees pop when you bend them. You are not old. You are perhaps 28, maybe 30. It is hard to say, because no one counts years here the way you're used counting them. Time is measured in seasons, in pregnancies, in how many winters since the big storm, in how many summers since the elk herd moved south and didn't come back. But your body feels older than your years. Your body feels like something that has been used hard and put away wet, as a farmer in a later century will say about a horse. Your teeth are worn, not from age, but from grit. The stone-ground grain that is the foundation of your diet contains tiny fragments of the grinding stone itself. And over years, those fragments sand down the enamel until the teeth are flat and pitted and occasionally, agonizingly, abscessed. Your gums bleed sometimes. Your joints are stiff, and your bones ache in a way that seems to come from inside them, from the marrow, from the deep mineral core, as though the bones themselves are tired. You do not know that this is vitamin D deficiency. You do not have a name for it. You might call it the winter sickness, or the bone ache, or simply the heaviness. You might not call it anything at all. It is just how the body feels here, in this place, in this season. Everyone's body feels this way by late winter. The children especially. The little ones who were born in autumn and spent their first months in the dark. They're the ones who worry you. Their legs sometimes bend in ways that legs should not bend. Their ribs feel soft when you hold them. You have seen children die from this. Not quickly, slowly. A failure to thrive that starts with weakness and ends with fever and then with silence. You press your lips to the top of your child's head. Asterisk alive. Still here. You stand. The cold hits your legs immediately. The shelter is not warm the way your bed is warm. The shelter is less cold than outside, and that is the best that can be said for it. You reach for your outer garment, a tunic of woven flax, layered over an inner garment of softer wool. The flax is rough. It scratches. You have worn it so many times that the roughness is mapped onto your skin. The places where the weave catches on your shoulders. The place at the left hip where the seam is slightly raised and rubs when you walk. Clothing. Think about this for a moment. Every inch of skin you cover is an inch that will not receive sunlight today. And today, like most days in this place and this season, the sun will be low and weak and filtered through a sky the color of wet slate. And even the skin you do expose, your face, your hands, will receive almost no UVB radiation. The photons that could trigger vitamin D synthesis in your epidermis are being absorbed by the atmosphere, scattered by clouds, deflected by the shallow angle of a sun that barely clears the treetops before it begins to set again. You do not know any of this. You know that the sun feels good on your face in summer. You know that you feel better when the days are long. You know that winter makes you tired, and that your bones ache less when the warm months come. These are observations, not explanations. The mechanism is invisible to you, is a process that will not be described by another human being for roughly 7,000 years. But your body knows. Your body is running the chemistry right now, or trying to with whatever it has. And what it has this morning is not much. Outside, the settlement is waking up. It is small, a handful of structures, 5, maybe 6, arranged in a loose cluster near the lake. Each one is partially sunken into the earth, with low walls of packed turf and timber and a roof that is barely taller than a standing person. They look, from a distance, like blisters on a landscape. Lumps of earth with smoke leaking from the top. Between the shelters, the ground is bare and trampled. Mud mostly. Dark, organic, boot-printed mud that will freeze by nightfall and thaw again by mid-morning. A few dogs, lean, wolfish, sharp-eared, are already moving around, sniffing at refuse piles, looking for anything edible. The dogs are not pets. They are not companions in the way you think of a dog. They are tools. They guard. They hunt. They eat scraps and bones and things that the humans will not eat, and in return they bark when strangers approach, and they help run down deer in the autumn. One of the dogs trots past you as you emerge from your shelter, and it glances at you with that sideways, assessing look that dogs have had for 15,000 years. It knows you. It knows your smell. It decides you are not relevant to its current project, which involves something half buried in the mud near the refuse pile, and it moves on. You move toward the central area, where the communal fire is kept. Someone has already been here. The fire is burning, not the embers of last night, but a fresh fire, built from dry birch logs that snap and pop and throw off sparks that float upward and vanish in the gray air. Birch burns hot and fast. It smells clean, resinous and sharp, a smell that cuts through the permanent background of smoke and damp and animal and human bodies and fermenting grain. A woman is kneeling by the grinding stone. She is older than you. Her hair is pulled back and tied with a strip of leather. Her hands are broad and strong, and her forearms are roped with the kind of muscle that comes not from exercise, but from years of the same repetitive motion. Push, pull, push, pull. stone on stone, grain between. She is grinding emmer wheat into flour, and the sound of it is the sound of this settlement, the sound of this era, the sound of the Neolithic itself. A low, rhythmic, endless scraping, like the earth slowly wearing itself down. She does not look up. She does not need to. She knows you are there. In a settlement this small, everyone knows where everyone is, always. Privacy is not a concept that exists in any meaningful way. You sleep in groups. You eat in groups. You grieve in groups. The boundary between your body and the community is thinner than you. Modern you, listening to this in your separate room, in your separate bed, in your separate life, can easily imagine. You kneel beside her. She shifts slightly to make room. You take a handful of grain from the shallow basket beside the stone and scatter it onto the surface, and begin to push the smaller stone across the larger one, crushing the kernels into a coarse, gritty flour that will be mixed with water and baked on a hot stone near the fire. This is breakfast. This is also lunch and dinner and every meal between. Grain, flat, dense, gritty bread, sometimes with dried fish, sometimes with the last of the stored hazelnuts, which are mealy and slightly bitter by this time of year, sometimes with a thin porridge made from the same flour, boiled in water until it thickens into a paste that fills the stomach without nourishing it the way the old foods did. The old foods. You have heard the elders talk about them, about the time before farming, or rather, about the stories their elders told them, which their elders told them, which stretches back into a past that has gone soft and mythological. A time when people followed the animals, when they ate what the land offered, fish from the rivers, meat from the hunt, roots and berries and the fat-rich organs of deer and boar and elk, when the bones were strong and the teeth were good and the winter sickness was not as bad. You don't know how much of this is true and how much is the way people always talk about the past, gilding it, smoothing the edges, forgetting the hunger and the fear and the children who died of things that had nothing to do with grain or sunlight. But you know this. Your teeth are worse than the skulls you sometimes find in the old places. The burial mounds by the lake, the ones that were there before your people came, the ones that belong to the ones who were here first. Their teeth, in those old skulls, are not as worn. Their bones are denser. Their spines are straighter. You have noticed this. You do not know what to do with the observation. Your child has followed you outside. She is standing at the edge of the shelter, squinting at the gray sky, wearing a woolen tunic that is too big for her. It was made for the boy, the one who is in the ground by the birch trees, and it hangs past her knees and makes her look like a small, serious mushroom. She is 3, maybe 3.5. She is thin, not starving, not neglected, but thin in the way that children in this place and this era are thin. Not enough fat, not enough of the right nutrients, the body directing whatever it is toward the brain and the organs and making do with what's left for the limbs and the skin and the hair. Her hair is dark, darker than yours, which has lightened slightly over the years, sun-bleached in summer, though summer in this place is brief. Her skin is, you do not think about her skin in terms of color. You do not have a category for it. It is simply her skin. It is lighter than the people in the old stories, the ones from the South, the ancestors who came from the warm lands many generations ago. It is darker than some of the children in the settlement, the ones whose families came from further west. It is skin. It gets cold and hot and scraped and bitten by insects, and sometimes it breaks open and bleeds, and then it heals. That is what skin does. But if a geneticist could examine your daughter, if someone could extract a cell from the inside of her cheek and sequence the DNA and read the letters, they would find something in transition. They would find a genome caught in the middle of shift. Some alleles ancestral, some derived, a mosaic, a work in progress. Your daughter is evolution in real time, and she doesn't know it, and you don't know it, and the woman grinding grain beside you doesn't know it, and the dogs don't know it, and the lake doesn't know it, and the gray sky that is refusing, once again, to let sufficient ultraviolet light through to the surface of the earth does not know it. Nobody knows it. It is just happening. The way erosion happens. The way rivers cut canyons. The way glaciers carve valleys. Slowly. Impersonally. One generation at a time. The day passes. You eat. You work. You tend the fire, repair a section of the shelter wall where the turf has crumbled, check the fish traps in the shallows of the lake where the ice is pulled back enough to reach them. The traps are woven from willow, thin, green, flexible willow branches bent into a cone shape, and inside one of them, there's a pike. Alive, angry, thrashing in the shallow water as you pull the trap onto the bank. You kill it quickly. A blow to the head with a stone. The thrashing stops. The eye goes flat. Fish. Wild fish. This is the old food. This is the food your body was built for. The food that carries the vitamin D that your grain-based diet does not. The pike's liver, in particular, is rich with it. A small, dark, oily organ that you will eat tonight, probably raw or barely cooked on a hot stone, because the old knowledge, the knowledge that the elders carry, the knowledge that is fading as farming takes over, says that the insides of fish are good for you. They make the bones strong. They make the babies well. The elders are right. They do not know why they are right. They do not know about cholecalciferol or UVB or melanosomes. But they are right. The fish liver is medicine. Every culture that has survived in high latitudes has learned this, independently, through millennia of observation and trial and error. Eat the fish. Eat the liver. Eat the fat. The body needs something that lives in the dark, oily places of cold water animals. And if you don't eat it, the bones go soft and the children die. This is folk medicine. This is pre-scientific knowledge. And it is, in this case, precisely correct. You carry the pike back to the settlement. Your daughter follows, dragging a stick through the mud, drawing lines that mean nothing and everything, the way children draw. Evening. The communal fire is high now. Someone has added oak, slow-burning, long-lasting, and the flames have settled into a steady, orange glow that throws moving shadows on the walls of the shelters and the faces of the people gathered around it. There are perhaps 30 people in this settlement. Maybe 35. You know all of them. You have known all of them for your entire life. Some are blood relatives. Some are not. The boundaries are blurry. Marriage, in this time and place, is not the rigid institution it will later become. People pair and unpair. Children are raised by the group as much as by individual parents. The child pressed against your side tonight might, in a few years, spend as much time in another shelter as in yours, learning skills from another woman, sleeping by another fire. This is how small communities work. This is how they have always worked. The modern fantasy of a nuclear family, 2 parents, 2 children, a locked door, and a private life, is, in the long view of human history, a bizarre and recent experiment. For most of the time your species has existed, life was this, a cluster of bodies around a fire, sharing food, sharing warmth, sharing stories, sharing the weight of being alive. And tonight, someone is telling a story. An older man. He is sitting on a log near the fire, and his voice is low and rhythmic, and the children have gone quiet. Even the restless ones, even the ones who were throwing sticks at the dogs 10 minutes ago. Because when this man speaks in this particular cadence, it means a story is happening, and stories in a world without books or screens or any other way to store narrative outside the human brain are the most valuable technology your species possesses. You do not catch all the words. The fire is loud and the wind is picking up and your daughter has fallen asleep against your arm, and her weight is pulling you sideways. And you are tired, bone tired, the deep fatigue that settles into your body every winter and does not lift until the first warm days of spring. But you catch the shape of the story, the pattern. It is an old one, a story about a journey, about people who walked a long way from a warm place to a cold place, and who had to learn new things to survive. New foods, new shelters, new ways of reading the sky and the water and the land. You have heard this story many times. Everyone has. It changes a little with each telling, a detail added here, a character shifted there, but the core is the same. The core is always the same. Asterisk, we came from somewhere else. We came a long way. It was hard. We survived. Asterisk. That is the story. That is the only story. Every myth, every legend, every sacred narrative your species has ever produced is a variation on that theme. We were in danger. We endured. We are here. You close your eyes. The fire warms one side of your face. The cold presses against the other. Your daughter breathes against your arm, slow and even, The way children breathe when they have surrendered completely to sleep, that total, trusting, absolute surrender that adults almost never achieve, that you yourself have not achieved in months, maybe years, because there is always something to listen for in the night, always some part of your brain standing watch. But tonight, just for a moment, you feel it, that loosening, that softening at the edges. The story is still going, the old man's voice rising and falling like wind over water, and the fire is warm, and the child is alive, and the pike is in your stomach, and the bones ache a little less than they did this morning. Tomorrow, the sky might clear. The sun might come through. You might stand outside the shelter and tilt your face upward and feel that warmth, that specific, tingling warmth that UVB makes when it hits bare skin, and your body will do what it has been trying to do all winter. It will make the molecule, the one it needs, the one that keeps you solid, or the sky will stay gray, and you will eat what you can, and the ache will continue, and you will carry your daughter into the shelter and curl around her and pull the hide over both of you and wait for spring. Either way, you will be here in the morning. Either way, the line continues. She does not have a name that we know. No one wrote it down. There was no writing. Her name existed only in the mouths of the people who knew her, and when the last of them died, the name died too. This is the fate of most human beings who have ever lived. Billions of names, spoken and loved and called across fields and firelit shelters and muddy paths, and all of them gone, dissolved into air, returned to silence. But her genes are not gone. If she survived, and someone in her line survived, because the line leads to now, leads to people alive today, then fragments of her DNA are still here, shuffled and recombined and diluted across 7,000 years of generations, but present. A fraction of a fraction of a fraction, carried forward in the cells of people who will never know her name, but who carry, in every cell of their bodies, a tiny, molecular echo of the woman who knelt by the grinding stone and killed the pike and closed her eyes by the fire while an old man told a story about a long walk from a warm place to a cold place. You might be one of those people. If any part of your ancestry traces to Northern Europe, you might be carrying a fragment of her. A stretch of chromosome 15, where SLC24A5 sits. A sequence of base pairs that she passed to her daughter, who passed it to her daughter, who passed it forward, and forward, and forward, through the Bronze Age and the Iron Age and the Roman occupation and the medieval period and the Industrial Revolution and 2 world wars and the invention of the internet and the moment, right now, tonight, when you are lying in the dark, listening to this, breathing slowly, and the genes she gave you are doing their quiet work inside your cells. She is in you, not metaphorically, literally, molecularly, the same DNA, the same letters, copied and copied and copied across 350 generations. And here it is, in your body, tonight, keeping you together. Rest with that for a moment. You don't need to think about it. Just let it be there. The way the ground is there under the building you're in. The way gravity is there, holding you to the mattress, to the couch, to whatever surface is keeping you from floating away into the dark. She is there, in you, and you are here, in the world she helped make possible. In part 4, we come home. We leave the settlement and the lake and the gray sky, and we return to the modern world, your world, and we ask the question that the whole story has been building toward. What happened to the crisis? Is it over? Or did it just change shape? Come back now. Come back from the lake and the fire and the gray sky. Come back from the settlement and the grinding stone and the woman whose name we'll never know. Come back to the room you are actually in, the one with the ceiling and the walls and the device that is playing this voice into your ears. Feel the surface under you. Not deer hide, not packed earth, cotton probably, or polyester, or some blend that was woven by a machine in a factory on the other side of the planet and shipped in a container across an ocean and sold to you in a store or delivered to your door in a cardboard box. And you never once thought about the thread count in terms of survival. That's the difference. That's the gap. The woman by the lake wrapped herself in rough flax because without it she would die of exposure. You wrapped yourself in whatever you're lying on because it was on sale, or because you liked the color, or because you didn't think about it at all. Fabric, for you, is not survival. It is preference. It is comfort. It is a purchase. And that gap, between her world and yours, between necessity and convenience, between a life organized entirely around not dying and a life organized almost entirely around something else. That gap is where our story turns. Because here is the strange, uncomfortable, quietly alarming truth. The vitamin D crisis that reshaped your ancestors' skin is not over. It didn't end. It changed. It modernized. It put on a different outfit and moved to a different address, and kept doing exactly what it has always done, starving human bodies of a molecule they cannot live without. Only now, it's not the angle of the sun that's the problem. It's you. Let me give you a number. 1 billion. That is the estimated number of people on Earth right now, tonight, as you listen to this, who are vitamin D deficient or insufficient. 1 billion. Roughly 1 in every 8 human beings currently alive does not have enough vitamin D in their blood to maintain optimal bone health, immune function, and metabolic regulation. 1 billion. In a world with supermarkets and supplements and fortified milk and medical knowledge that the woman by the lake could not have dreamed of. In a world where we understand, down to the molecular level, exactly what vitamin D does and exactly how to get it. In a world where a bottle of vitamin D3 capsules costs less than a cup of coffee. 1 billion people are deficient. How? The answer is so simple it's almost embarrassing. We went inside. Think about your day. Not today specifically, though you can if you want. Think about a typical day, an average day, a day that represents the general shape of your life. What time did you wake up? Were you already indoors? Of course you were. You woke up in a bedroom, inside a building, behind walls and a roof and windows that block virtually all UVB radiation. Glass, ordinary window glass, absorbs UVB almost completely. You could sit in a sunbeam by your window all day, feeling the warmth on your skin, and your body would produce essentially no vitamin D. The visible light gets through. The infrared gets through. You feel warm. You feel bright. But the specific wavelength your skin needs, 290 to 320 nanometers, is stopped cold by the glass. So you woke up indoors. Then what? You went to the kitchen. Indoors. You ate breakfast. Probably not pike liver. Probably cereal or toast or yogurt or eggs or nothing at all because you were running late. Then you went to work or to school or to wherever your day takes you. And you probably went there inside a vehicle, a car, a bus, a train, a subway, all of which have glass windows that block UVB or no windows at all. You arrived at a building. You went inside the building. You stayed inside the building for 8, 10, 12 hours, under fluorescent light, or LED light, or the blue-white glow of a screen, none of which contain UVB radiation. Your skin received nothing. Your epidermis sat idle, the 7-dehydrocholesterol molecules waiting for photons that never came, like workers at a factory where the shipment never arrives. Then you went home, inside a vehicle, to a building. You close the door. You turn on the lights, artificial lights, which do a remarkable job of mimicking the visual spectrum of sunlight, but contain absolutely no UVB. You ate dinner, possibly something fortified, possibly not, probably not enough vitamin D either way. You watched a screen. You scrolled. You read. You did whatever you do in the hours between dinner and sleep, and then you lay down, in the dark, and put this voice in your ears. How many minutes of unfiltered, direct sunlight did your skin receive today? For most people in the industrialized world, the answer, on a typical day, is somewhere between 0 and 15. 0 and 15. Your ancestors, even the farmers, even the ones with the grain-based diets and the covered skin and the gray northern skies, even they spent hours outdoors every day. Hours. Tending fields, fetching water, repairing shelters, walking to the next settlement, standing in the open air. Their exposure was limited by latitude and season and cloud cover, but it was not limited by architecture. They did not spend their lives inside sealed boxes. You do. And your body, the same body, essentially unchanged in its fundamental biology from the one that walked out of Africa 70,000 years ago, is responding the way it always responds when it doesn't get enough vitamin D. Your bones are losing density. Slowly. Imperceptibly. But steadily. Your immune system is running at reduced capacity. Your mood is heavier than it needs to be. The fatigue that follows you through winter is not just seasonal melancholy. It is, in part, chemical, neurological, a brain that is not getting enough of a molecule it was designed to have. The crisis is the same. The setting is different. The woman by the lake had a gray sky. You have a ceiling. Same result. There's a concept in evolutionary biology called the mismatch hypothesis, and it is one of the most useful lenses through which to understand why modern life feels so often like something is slightly wrong. Not catastrophically wrong, not emergency wrong, just off, like a shirt button one hole too high, like a note played slightly flat, a persistent, low-grade sense that the body and the world it inhabits are not quite aligned. The mismatch hypothesis says this. Your body was shaped by natural selection over hundreds of thousands of years to function in a specific set of environmental conditions. Those conditions included high levels of physical activity, a diet of wild plants and animals, exposure to sunlight, close social bonds with a small group of known individuals, long periods of rest alternating with short bursts of intense effort, and a world that was mostly quiet, mostly dark at night, and mostly outdoors. And then, in the last 10,000 years, and especially in the last 200, we changed everything. We changed the food. From wild game and forage plants to processed grain and refined sugar and foods that have been engineered at the molecular level to trigger reward circuits in the brain that evolved to value calorie-dense foods in an environment where calories were scarce. We changed the movement. From walking 10 to 20 kilometers a day, the estimated average for a Paleolithic human, to sitting in chairs, in cars, at desks, on couches, for an average of 9 to 10 hours a day in the developed world. Your spine, which evolved to be upright and mobile, is spending most of its existence in a position it was not designed for. We changed the light. From a 24-hour cycle of bright sun and true dark, the cycle your circadian rhythm was calibrated to a world of artificial light. Blue spectrum light from screens at midnight. Dim, inadequate light during the day in offices with no windows. A flattening of the light cycle that confuses the suprachiasmatic nucleus, the tiny cluster of neurons in your hypothalamus that acts as your master clock and disrupts melatonin production and sleep architecture, and a cascade of hormonal processes that depend on the body knowing, with confidence, what time it is. We changed the social structure from small, interdependent groups of 30 to 50 people, the size of a hunter-gatherer band, the size of a Neolithic settlement, roughly the number of faces and names a human brain can track with deep familiarity, to cities of millions, where you're surrounded by people at all times and deeply connected to almost none of them. The loneliness epidemic is not a failure of character. It is a mismatch, a brain built for a village, living in a metropolis. And we changed the skin's relationship with the sun. This is the one that matters most tonight, the one that ties the ancient story to the modern body. Your skin was the product of millennia of fine-tuning. Whether your ancestors lightened it to survive in the north, or kept it dark to thrive in the tropics, or found some intermediate shade in the latitudes between, the calibration was precise. It was designed for a specific amount of sun exposure, a specific lifestyle, a specific balance between too much UV and too little. And we've blown that balance apart. Here is where it gets paradoxical. Here is where the modern world ties itself in a knot that would make the woman by the lake shake her head, if she could understand it. We know about vitamin D now. We understand the chemistry. We can measure blood levels of calcidiol with a simple test. We can synthesize vitamin D3 in a laboratory and put it in capsules and sell it in every pharmacy on the planet. We can fortify milk and orange juice and cereal. We have, in other words, the knowledge and the technology to solve the problem completely. And yet, 1 billion people are deficient. Why? Partly because of the indoor life we just described. Partly because of diet. Modern processed food is not much better than Neolithic grain in terms of vitamin D content, and in some ways worse, because at least the Neolithic farmers occasionally caught a fish. But partly, and this is the part that is almost funny in a dark and deeply human way, because we are afraid of the sun, not irrationally afraid. Skin cancer is real. Melanoma is dangerous. Ultraviolet radiation does cause DNA damage in skin cells, and decades of public health messaging have drilled into the modern mind a simple equation. Sun equals danger. Wear sunscreen. Cover up. Stay in the shade. Avoid the midday sun. And this messaging has been effective. Skin cancer rates in some populations have stabilized or declined. Sunburn rates have dropped. Dermatologists have saved lives, genuinely and measurably, by teaching people to protect their skin. But the messaging has also had an unintended consequence. People are now so thoroughly afraid of the sun that they avoid it almost entirely. Sunscreen with an SPF of 30, the standard recommendation, reduces UVB absorption by about 97%. SPF 50 reduces it by about 98%, which means that even when people do go outside, even when they stand in direct sunlight, their skin is producing almost no vitamin D. The very thing that saved Northern Europeans from the bone-softening death of rickets, the ability of lighter skin to absorb more UVB, is being chemically negated by a cream that we apply every morning out of a perfectly reasonable fear of a different disease. We lightened our skin to let the light in, and then we invented a paste to keep it out. The woman by the lake had a gray sky between her and the sun. You have a gray sky and a roof and glass windows and sunscreen and an indoor lifestyle and a grain-heavy diet and a cultural fear of the very star your body was built to need. Layer upon layer upon layer of separation. Between your skin and the light. Between your body and the molecule. The crisis didn't end. It compounded. There's one more thing. One more thread. The vitamin D crisis didn't just change skin. It changed behavior. It changed culture. It changed what people eat and where they build and how they raise their children and when they go outside and what they wear. And it changed something even deeper than that. It changed how we think about each other. Because skin color, the scar that vitamin D left on the human body, became, over the last few centuries, the basis for one of the most destructive systems of categorization and hierarchy that our species has ever invented. A system that looked at the surface of the body, at the amount of melanin in the epidermis, at the biological response to a photon shortage, and decided that it meant something about the person inside, about their intelligence, their worth, their right to freedom and dignity in life. Race, the idea of race, built on a misunderstanding of a survival mechanism, built on a failure to see that dark skin and light skin are not opposites, but answers to the same question, asked at different latitudes. Both optimal, both precise, both the product of the same ancient, impersonal, indifferent process of selection that cares about nothing except whether the baby survives. The woman by the lake was not white. She was not a race. She was a body calibrated to a latitude, trying to make enough of a molecule to keep her bones together. And if she could meet the woman who ground grain in the sun on the banks of the Niger 5,000 years ago, a woman with dark skin, dark eyes, strong bones, a body perfectly tuned to a different angle of light, neither of them would look at the other and see a category. They would see a woman, grinding grain, surviving. That is what we are. All of us. Every shade, every latitude, every variant of every gene. We are bodies, calibrated to light, trying to make it through the winter. And the winter comes for everyone. We've been traveling a long time. From the clean rooms of Dublin to the shores of a Swedish lake to the glow of the screen in your hand. From the deep past to the present to the strange, mismatched, beautiful, broken world you live in. Part 5 is the exhale, the landing, the place where the story comes to ground and you come to stillness. We'll talk about what it means to be here, at the end of the chain, the latest draft of the oldest document. And we'll say goodnight. You're still here, or some of you is still here, some part of you. The part that floats near the surface when sleep is close, the part that can still catch a word or a phrase and turn it over like a smooth stone found on a beach. That part is still listening. And that's enough. That's more than enough. We've come a long way tonight, you and I. We started with your hand, the back of your hand, the skin there, the color of it. And we followed that color backward through time, through labs and ice cores and grinding stones and gray skies, all the way to a molecule. A single molecule. Vitamin D. The quiet architect of your skeleton. The reason your bones hold you up. The reason your ancestors' skin changed color. The reason you exist. And now we're here. At the end. Or not the end. There is no end to this story, because the story is still being written in your cells tonight as your body does its slow, ancient maintenance work in the dark. But the end of what I can tell you. The end of what words can carry. After this, the rest is yours. I want to tell you something about the human species that is easy to forget. It is easy to forget because the news is loud and the headlines are alarming and the algorithms that govern what you see on your screen are optimized for fear, because fear keeps you scrolling, and scrolling keeps the lights on in a server farm in Oregon or Virginia or somewhere on the coast of Ireland where the air is cool enough to keep the machines from overheating. The thing that is easy to forget is this. You should not be here. Not you, personally, though that is also true, and we'll get to it. The species. Homo sapiens, the whole improbable, bickering, cathedral building, war fighting, poem writing, child carrying enterprise of modern humanity. We should not be here. The odds were against us. Not slightly, overwhelmingly. At almost every stage of our history, there was a moment when the story could have ended. A bottleneck, a collapse, a point where the population dropped so low, where the environment shifted so violently that extinction was not just possible, but probable. Let me walk you through a few. Gently, like reading the chapter titles of a very long book. You don't need to remember them. Just let them pass through you, one by one, like beads on a string. 74,000 years ago, a supervolcano called Toba erupted on the island of Sumatra. It was the largest eruption in the last 2 million years. It blasted roughly 2,800 cubic kilometers of rock and ash into the atmosphere. The skies darkened. Global temperatures dropped by as much as 15 degrees Celsius for years. A volcanic winter settled over the planet like a lid on a pot. Some geneticists believe that the human population, already small, crashed to fewer than 10,000 breeding individuals. Perhaps fewer than a few thousand. A genetic bottleneck so tight that it left a scar in our DNA, a reduction in genetic diversity that is still visible today. Humans, as a species, have less genetic diversity than a single troop of chimpanzees in a West African forest. That is how close we came. That is how thin the thread was. We survived. 40,000 years ago, we shared Europe with the Neanderthals, a sister species, robustly built, cold-adapted, with brains as large as ours, and a track record of survival in glacial conditions that stretched back hundreds of thousands of years. They should have outlasted us. By every measure of endurance and adaptation, they were better suited to the ice. They didn't outlast us. They vanished, absorbed partly into our gene pool. If you were of European or Asian descent, roughly 1 to 4% of your DNA is Neanderthal, a ghost in the machine, a whisper from a species that no longer walks the earth. But as a distinct lineage, they are gone. And we remain. We survived. 26,000 years ago, the last glacial maximum. Ice sheets kilometers thick covering northern Europe, northern Asia, northern North America. Sea levels dropped by 120 meters. The habitable zone for humans in Europe shrank to a handful of refugia, small, relatively sheltered areas in Iberia, the Balkans, the Italian peninsula, where pockets of people held on against the cold and the scarcity and the relentless compression of the world into smaller and smaller patches of livable ground. They held on. They painted caves. They carved figurines of women with wide hips and heavy breasts. Fertility symbols, perhaps, or goddesses, or simply the image of what a well-fed, healthy body looked like in a world where well-fed and healthy were rare enough to be sacred. We survived. 12,000 years ago, the Younger Dryas. A sudden, savage return to glacial conditions after a period of warming. The cause is still debated. A massive influx of fresh water into the North Atlantic from melting glaciers, disrupting the thermohaline circulation, shutting down the Gulf Stream like a switch. Temperatures in the northern hemisphere plummeted. In decades, not centuries, decades, the people alive at the time, the people on the edge of inventing agriculture, the people whose grandchildren would plant the first wheat and build the first permanent settlements, had to endure 1,000 years of cold that came out of nowhere and threatened to undo everything. We survived. 5,000 years ago, the collapse of the first urban civilizations in the Indus Valley in Mesopotamia. Drought, salinization, overpopulation, the same pattern that would repeat again and again in different places with different names. The Bronze Age collapse, the fall of Rome, the famines of the 14th century, the plagues that killed a third of Europe. Again and again and again, the book was held over the fire. The pages curled, the edges blackened, and someone, somewhere, pulled it back. Not a hero, not a king, usually no one whose name we know. A woman who kept her child alive through a famine. A man who carried seed grain 200 kilometers to a place where it might grow. A small group of people who decided, without knowing they were deciding anything, to keep going. To have one more child. To plant one more field. To get through one more winter. And the book survived. You were reading it. Now, you, not the species. You. The probability of your specific existence is a number so small that mathematics barely has a way to express it. It is not metaphor when people say you are a miracle. It is arithmetic. Consider the chain. Every one of your direct ancestors. Every single one. Stretching back through the Neolithic and the Mesolithic and the Upper Paleolithic and beyond, back to the first Homo sapiens in East Africa and further, back to the hominins and the primates and the early mammals and the first vertebrates and the first multicellular organisms and the first cells. Every single one of them survived long enough to reproduce. Not one of them died in childhood. Not one of them was killed before having offspring. Not one of them was infertile. Not one of them was the child who didn't make it. Every single one was the child who did. The woman by the lake. She was one of them. If your ancestry passes through Northern Europe, she might be one of yours. She survived the winter. She survived the bone ache. She survived the gray sky and the gritty bread and the burial of her first child and the long, slow, invisible work of selection that was reshaping her genes without her knowledge or consent. She made it, and her daughter made it, and her daughter's daughter, and on and on and on, through centuries that have no names, through lives that left no record except the genes themselves, the letters, the base pairs, the tiny molecular instructions that were copied and copied and copied and carried forward through every plague and famine and war and migration and disaster, all the way to the moment when a specific sperm met a specific egg and the combination. Your combination, the unique, never before seen, never to be repeated arrangement of 3 billion base pairs that is you, clicked into existence. You are not generic. You are not replaceable. You are not a rough draft. You are a specific edition, a one-of-one print, a book that has never been written before and will never be written again. And the fact that you are here, lying in the dark, breathing, listening, your heart beating at whatever pace it beats, your blood carrying vitamin D or not enough vitamin D through vessels and capillaries in the tiny, exquisite architecture of your circulatory system. The fact that you are here means that every filter, every bottleneck, every crisis, every toba, and every ice age, and every famine, and every vitamin D emergency that should have ended your line, didn't. The thread held. It is holding now. It will hold tomorrow. I want to talk about rest now, about what your body is doing, or about to do, or is already doing if you've drifted ahead of my words. Sleep is not the absence of activity. You know this, probably, but it bears saying, tonight, because it connects to everything we've talked about. When you sleep, your body does not shut down. It shifts, like a factory that changes production lines at night. Same machines, different product. During the day, the product is consciousness, movement, response, alertness. During the night, the product is repair. Your glymphatic system, a waste clearance network in the brain that was only discovered in 2012, which means that for all of human history before that, we did not even know existed, opens up during sleep. The channels between brain cells widen. Cerebrospinal fluid floods through the tissue, carrying away the metabolic waste that accumulated during the day. Beta amyloid, tau proteins, the molecular debris of a brain that has been thinking and feeling and processing for 16 hours. This is why sleep deprivation destroys cognitive function. Not because the brain is tired. Neurons don't get tired the way muscles do. Because the brain is dirty, is swimming in its own waste products, and only sleep opens the drains. Your immune system ramps up during sleep. Cytokine production increases. T-cell function improves. The body shifts resources from the muscles and the conscious brain to the immune system and the repair mechanisms that patch damaged tissue, consolidate memory, and regulate hormones. Vitamin D plays a role in this. Of course it does. It plays a role in everything. Calcitriol, the active form of vitamin D, influences the expression of over 1,000 genes. 1,000. It modulates immune cell activity. It affects insulin sensitivity. It influences serotonin synthesis, which affects mood, which affects sleep quality, which affects immune function, which circles back to vitamin D in a feedback loop so intricate that the body itself probably doesn't fully understand it. This is what you are, a system of loops, a web of dependencies so dense and interconnected that pulling one thread, removing one molecule, changing one photon's path, sends ripples through the entire structure. And sleep is when the structure maintains itself. So what you're doing right now, lying still in the dark, letting the conscious mind loosen its grip, is not laziness. It is not waste. It is the most ancient and essential act your body performs. It is the thing your body has been doing every night since the first organisms developed a circadian rhythm, billions of years ago, when the distinction between day and night first became meaningful to a living cell. You are doing what life does. You are resting so you can continue. Let me bring it together now. Let me weave the threads into a single cord. Not tight, loose, a soft braid, something you can hold without gripping. You are a body. That body is made of cells. 37 trillion of them, approximately. Each one containing a copy of your genome. 3 billion base pairs of DNA, coiled and compacted into 46 chromosomes, carrying the instructions for building and maintaining the organism that is you. Those instructions were not written by a single author. They were edited, over millions of years, by the patient, impersonal hand of natural selection, in response to the environments your ancestors lived in. Heat and cold, feast and famine, light and dark. One of the most recent edits, recent enough that the ink is barely dry, in evolutionary terms, was the vitamin D edit. The lightening of skin in northern populations. A molecular adjustment triggered by a crisis of light and diet and latitude that swept through the genome in a few thousand years and left its mark on the back of your hand. That edit is not the end of the story. It is not even a chapter. It is a sentence. A single sentence in a book that has been written across deep time by the accumulated survival of every organism in your lineage, from the first cell to the woman by the lake to your parents to you. And you're not the last sentence, either. If you have children, or if you already do, the book continues. Your addition, your specific arrangement of alleles, your unique draft, is shuffled and recombined and passed forward, and the editing continues, and the story goes on. And if you don't have children, the book still continues. Because your genes are shared. Your siblings carry most of them. Your cousins carry many. The human population is not a collection of isolated lines. It is a web, a river delta, a braided stream where the water separates and merges and separates again, and no single channel is the whole river, but every channel is part of it. You are part of the river. You have always been part of the river. And the river is old and slow, and it has survived things that should have stopped it. Volcanoes, ice ages, famines, plagues, the slow, grinding pressure of a molecule deficit that warped bones and killed children and reshaped the surface of the human body across an entire continent. The river survived all of it. And you're the river, tonight, flowing through the dark. So here's what I want you to carry in a sleep. Not a fact, not a gene name, not a number, a feeling. The feeling of being held. Not by arms, by time, by the accumulated weight of every life that led to yours. by the sheer improbability of your existence and the sheer stubbornness of the process that produced it, by the knowledge, not the intellectual knowledge, the felt knowledge, the body knowledge, that you're not alone in the dark. You have never been alone in the dark. The dark is where your species has rested every night for 300,000 years, and every one of those nights, the morning came. The morning will come tomorrow. The light will return. The same light, the same star, the same UVB photons that your ancestor's skin was reshaped to receive. They will be there, on the other side of the night, waiting, and your body will know what to do with them. It has always known. It has been practicing for 100,000 years. Thank you. I mean that. Thank you for your time tonight. Time is the only thing any of us actually has, the only currency that can't be earned back, the only resource that the richest and the poorest share in equal uncertainty. And you spent some of yours here, listening to a story about a molecule in a star and the skin on the back of your hand. That means something to me. If this story helped you, if it made you feel something, or think something, or simply gave you a place to rest your mind while your body did its ancient, necessary work, then I'm glad. That's what it was for. If you'd like to leave a like, or a comment, or subscribe so you're here the next time we walk through the deep time together, that's wonderful. It helps this reach other people who are lying in other rooms, in other cities, in other time zones, looking for a voice in the dark. And if you'd like to tell me where you're listening from, just the city, or the country, or even just the weather outside your window, I'd love that. Because this community is one of the oldest human technologies there is. A group of people gathered around a story, in the dark, at the end of the day. The setting has changed. Fire to screen, cave to bedroom, 30 people to 30,000, but the shape is the same. The need is the same. We are the same. One last thing. Tomorrow, or the next day, or whenever it feels right, go outside. Even briefly. Even if the sky is gray. Even if it's cold. Stand somewhere where the light can reach your face and your arms and the backs of your hands. And close your eyes, and tilt your head up, and let the photons do what they have been doing since long before there were humans to receive them. Let the light in. Your skin knows what to do. It has known for a very long time. Rest well tonight. You have earned it. Not just today. Over 100,000 years. Your lineage has earned this rest. Every ancestor who fought through the dark, who survived the winter, who carried the seed grain, who buried the child and kept going, who stood in the weak northern light and let their body change so that yours could exist, all of them earned this moment for you. This quiet, this dark, this breath. So take it. Close your eyes, if they are not already closed. Let the weight of your body press into whatever is holding you. Let the muscles in your jaw go slack. Let your shoulders drop. Let your hands uncurl. You are the latest word in a very long sentence. And the sentence is beautiful. And it is not finished. But this page is done.